Assalamu alaikum students. How are you all? Hope you are very good. Children, in today's session, I am going to revise your fourth chapter, that is motion and time. What do you mean by motion? An object is said to be in motion if it changes its position with respect to its surroundings in a given time. It's called motion. Motion is a common experience in our life. Let us see what is rest. An object said to be at rest if there is no change in its position with respect to its surroundings in a given time. A body may be at rest with respect to one set of surroundings and at the same time it is in motion with respect to another set of surroundings. Thus, motion is relative to the observer. Now, we can also say what are uniform and non-uniform motions. If a body covers equal distances in equal intervals of time, it is said to be in uniform motion. Then we see what is a non-uniform motion. If a body covers unequal distances in equal intervals of time, it is said to be in non-uniform motion. Now let us see some examples of uniform and non-uniform motion. Movement of hands of a clock is in uniform. It is an example of uniform motion. A boy cycling in a crowded place is an example of non-uniform motion. Movement of a housefly is non-uniform motion, and a train entering into a railway station, kite in the air are the examples of non-uniform motion, and the fan in an air cooler running at a fixed speed and rotation of the earth comes under uniform motion. Now we are going to see types of motion. Considering the direction of motion, what differences do you notice in the above examples? A car traveling along a straight road, motion of blades of a ceiling fan, motion of a needle in a running sewing machine, motion of pendulum in an old clock, in an old wall clock. Now, if a car is traveling along a straight road, then that comes under translatory motion. Motion of blades of a ceiling fan exhibits a rotatory motion. Motion of needle in a running sewing machine is an example of oscillatory motion. And motion of pendulum in an old wall clock is also an example of oscillatory motion. Now, based on the path taken by the bodies in motion, we have classified the motions of bodies into translatory motion, rotatory motion, and oscillatory motion. Now, let us see here what is a translatory motion. If all the parts of a moving body move in the direction of motion, then the motion is said to be translatory motion. Now, we are having two types of translatory motions. They are rectilinear translatory motion and curvilinear translatory motion. Now, if you see rectilinear, if your body in translatory motion moves along a straight line, then the motion is called as rectilinear motion. For example, we can say movement of a train on tracks, motion of coins on a carom board, motion of a mango falling from tree are the examples of rectilinear translatory motion. Next is curvilinear translatory motion. If your body in translatory motion moves along a curved path, then the motion is called as curvilinear translatory motion. For example, seconds hand of your watch, movement of a needle and a speedometer of a car exhibits curvilinear motion. Now we see what is rotatory motion. Rotatory motion means that motion of all particles of a moving body follow a circular path with respect to a fixed center or axis of rotation. Now we can see examples here. The blades of a fan, ceiling fan, and rotation of the earth, moving of a giant wheel, moment of top, moment of hands of a wall clock, and motion of wheels of an object, motion of the earth around the sun are the examples of rotatory motion. Now we see what is oscillatory motion. The to and fro motion of an object about a fixed point always following the same paths is called oscillatory motion. Now we can say examples of a needle of a sewing machine, a girl swinging, the movement of a swing, and also the movement of a pendulum of a wall clock and table fan moving, motion of a table fan. These are the examples of oscillatory motion. Now we see what is speed. Many objects in the world around us are moving. To compare how fast they are moving, we need to know their speed. The odometer in a vehicle shows the distance traveled in kilometers, and the speedometer, the speed of the journey in kilometers per hour. So, these are showing the speed of an vehicle. How to calculate the average speed? First, we see definition of a speed. We can define speed of an object as the distance traveled by it in a unit of time. Now we are having here formula of average speed. Average speed is equal to total distance traveled by time interval, or average speed is equal to total distance traveled by total time taken to travel the distance. Here units of speed. The formula is speed is equal to distance by time, a simple formula, and the unit of speed must be a unit of distance divided by a unit of time. So we measure this in kilometers per hour or meters per second. Let us see about time. We use the word time very often in our daily life. If we observe some examples where we use the time, we use the time for different situations without using the word time. We express the duration of time like so late, so early. How do we measure or estimate time? So there are some instruments for measuring time. They are In olden days, we have used fortnight, week, minutes, hours, month, season, ayanam, and then so these are the units of measuring time in olden days. And then sundial, sand clock, water clock are also used primitively to measure the time. Nowadays, we are using digital clocks, electronic clocks, quartz clocks for measuring time as you are seeing in this picture. We can use units foot of time like 60 seconds is equal to 1 minute, 60 minutes is equal to 1 hour, 24 hours equals to 1 day, 365 days equals to 1 year, and 10 years equal to 1 decade, 10 decades equals to 1 century, and 10 centuries is considered as 1 millennium. So the basic unit of time here is a second, and then the larger units of time are minutes and hours. So children, we continue with our next lessons revision later. Now, up to that, be happy. Allah Hafiz.